Ladies and gentlemen, please welcome our next speaker, Daniel Hiller, presenting the topic, KubeVirt, making running virtual machines in a Kubernetes cluster a mainstream activity.
Hey, hello everyone, how are you doing? Okay, so my talk will be about, I guess, something like a contradictory topic, like why would you even need like virtual machines inside a Kubernetes cluster probably? And I'm trying to answer these questions during this talk. Also, I'm going to try to present you a live demo of some things that you can do with KubeVirt. Hopefully the demo gods will be with me today. So I'll do a little bit of a prayer, I think, and I hope you can join me in so that everything goes right. Okay, to my person, I'm a software engineer at KubeVirt. I'm working for Red Hat. I'm around 5 years in the project right now. I've been working with databases and stuff and like boring Java and such things. No, I'm just kidding. A friend of mine is sitting there. The last 5 years I've been maintaining the KubeVirt CI ecosystem. With my previous speaker, the previous speaker talked about like trying to do GitOps on KubeVirt, and that's what we're actually doing. And lots of things like ring the bell to me. There are a couple of very smart ideas. I just want to pitch it because I think it should be really interesting for you probably if you're interested in DevOps. Okay. Yeah, you can, if you want, you could look at my homepage or, I forgot to update the Twitter com. I have only a Mastodon account. I don't use Twitter anymore. And my GitHub handle is dhiller. Okay, what is this about? Again, this is about like running virtual machines inside Kubernetes clusters and why you would have the need for this. So my first couple of questions would be, who is familiar or is using Kubernetes? Okay, a couple of people. And who is familiar or is even using KubeVirt? Okay, great. So hopefully I can convince you to use it afterwards if you have the need for that, but I figure that you're here for a reason. So let's try to help you understand the use cases, and maybe you can come up in the Q&A section with some other use cases that I might not even have imagined. The Kubernetes stands in contradiction with virtual machines. Kubernetes is, of course, like a platform where you can run your containers in, and it gives you a lot of like boilerplate stuff, so you don't have to handle this yourself, like restarts and whatever. Virtual machines, on the other hand, are running on a hypervisor, normally on most of the times bare metal, but in recent years there has been support for running virtual machines also on the cloud. I'm just reading this because I'm always getting this wrong, so bear with me. Kubernetes is a portable, extensible open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. So it tries to fix or like support you in most of the problems that are coming when you want to run like your application on a scale and like automatic restarts and all these things. Virtual machines, on the other hand, try to solve something different. They are like a container for whatever software you have, but not like a real bare metal thing, but like you have something that is emulated on the node where it's running. So it is a complete operating system that is running inside the virtual machine. That is the contrast. In contrast to the container, which is doing something different. And of course, it needs somehow a physical computer underneath, of course, but both do that at some point. So let's take a quick look at the diagram here. So this is like what the layers of the containers versus virtual machines are. So you have normally an app that is containerized inside a container and is running inside its container and is run by a container runtime on an operating system on the underlying hardware. Versus a virtual machine that also has some apps running there. Most of the time, this is the difference that there might be several applications running on the same system at the same time. Also with binaries and libraries and operating system and all that stuff running on a hypervisor, which is then also running on an operating system and on hardware. So now let's get back to the question that I had initially. Why am I using this? Or why would I be needing to use this? I had myself a very old virtual machine, for example, that I had like lying around, like a small Windows XP, if anyone knows that operating system even. And this was like lying around, and I was thinking about how I could reuse that. That's just one case. I would not want to have it like on all day somewhere, but I would like want to like pull it up whenever I need it, and I would then give it to my kids playing those learning games on this one because it's very old, and my kids are a little bit older now, so they don't need it anymore. But that was the time. This is one use case. Or when you have this, I figure that probably some people still have like those old machines that are running some services that they might be hiding in some closet, and it's still running and it's still doing its job. But if you are needing to maintain that system, or if like someone stumbles over the cable and the power gets lost, then you might lose some service that might be crucial even. So to get back, how can I, in general, get some virtual machine that is completely somewhere else, but what my containers are talking to probably, how can I get it closer to where it is used? That's one of the main ideas, what we want to solve. Yeah, let's skip that. I think that's an old one that you have seen already. So yeah, what is KubeVirt? KubeVirt is a platform basically and an extension to Kubernetes. And it enables you to run virtual machines inside a Kubernetes cluster. And also it enables you to use the standard Kubernetes objects that enable it, like for example, to front a virtual machine that is running inside the cluster with a service object, for example. So actually, this is important. So this is the initial. I think the initial pitch for this project. So there was the need that people had virtual machines that they wanted to move inside the Kubernetes cluster, and actually this is exactly what this project does. So let's skip that. I said that. Again, this is also like I said it. So let's just look at the YAML file, which actually is like the description of a KubeVirt virtual machine. So most of the time, like basic YAML, which you should be familiar with if you're working with Kubernetes, you should be pretty understandable what it's doing here. So there is also like a spec section where you have the definition. At this point, for example, is there a lighter in here? I don't know. You can see, for example, like the spec has top running false. This means that initially when the virtual machine is created, it's not running. That's an interesting point because you might want to have this running whenever it's created. Then there is the specification of the devices that are attached to the virtual machine. And this is basically like you work with other Kubernetes resources. You can, for example, like attach like This is not shown here. This is a special thing like a container disk, which I will not go into detail. Basically, that container disk is just like an image that you can attach to the virtual machine and that you can run then. Well, that is available to the virtual machine, you would say. Normally, you could also like attach persistent volume claims, if you know, and anything else that are somehow accessible through the Kubernetes ecosystem that your cluster is operating on. Okay, so much for theory. So what I'm going to show you now is I'm going to do a live demo where I am going to import a virtual machine disk, like a QCOW2 file, if some people probably might know that. Then I'm going to convert that image. Actually, I'm not doing it. The machine is doing it for me, but yeah, it's converted into something that KubeVirt can use. Then I'm actually creating the virtual machine with that image. And then I'll have my virtual machine running inside the KubeVirt cluster, inside the Kubernetes cluster. Demo time? Not yet. I just want to talk a bit about how the demo itself is organized. So let's somehow imagine I have two services. One is an external service that is running on a virtual machine that is outside the Kubernetes cluster. And the other service is something that is using that external service. So that external virtual machine service. And what I want to do, of course, is because only this other service is using the virtual machine service. So I want to bring it closer into that Kubernetes cluster and then have it like every other service running inside that Kubernetes cluster. I'm using the KubeVirt CI demo environment, which is part of the KubeVirt project, which gives me a set of cluster nodes of a containerized Kubernetes cluster that is running on my local machine, which I'm using for demo purposes. So this is a Dockerized Kubernetes cluster, which has like pre-pulled images, so that this should be pretty fast. I have some components I've enabled. There is a containerized data importer that is somehow required for interacting with storage and Kubernetes and KubeVirt. Then Rooksav is a backend storage provider for local use, and normally I would also have Prometheus and Grafana for monitoring, but I must admit that I didn't get that working for that, sorry. So I can't show you monitoring, but I think that the other things might be pretty much enough to see for today. If you can, I can give you pointers, or you can probably also look at the documentation. It should be pretty easy to get that running if you are interested to look at that. Okay, so let's see. Oh no. Of course, my preparation has failed. Okay, so let's see. Can you, by the way, is that big enough? Can you see everything? Should be okay? Okay. Yeah, that's a problem with live demos, right? If it's not working, it's not working. So let's see. So okay, now I'm in the step that I'm deploying KubeVirt on the local Kubernetes cluster. This should give me the ability to run the virtual machine. And the next one, which I will then do is I will import the virtual machine image. But yeah, it's taking a while. Note to myself, next time, be even better prepared. So while we're waiting, I can probably get back to what I also want to talk about. I also want to show not only the VM import, but also the LiveMigration, which does anyone know what LiveMigration is for virtual machines? Okay, no hands? 2 hands, okay. So just in a nutshell, like LiveMigration is the migration of a virtual machine from one node to the other. So without switching it off, like live. So you are just switching the node underneath the virtual machine while still the machine is running, which is probably pretty interesting for people who are like having to maintain nodes that might need to get restarted. This comes in very handy. If you're going to drain the node, for example, like you can configure a virtual machine automatically so that it just migrates to another node without you needing to do anything. And also I'm going to show Snapshot and Restore, which is like also a virtual machine feature, which most hypervisors, of course, like provide. You can just like from a created snapshot, you can restore a virtual machine to a previous state. That's also what I'm going to show. It will be pretty simple what I'm showing, but I think it demonstrates enough. So okay, let's talk about the project. KubeVirt is an open source project with Apache license. The latest release was in March, the version 1.2. We have a release schedule that is in sync with Kubernetes releases. Our releases are tested on the latest 3 minor Kubernetes releases. So like at the moment, for example, we are testing against 130, 129, and 128. So that the next release will be ready when Kubernetes 1.30 is released so that it will be comfortable with it and working with it. As of May 2024, we have 5,100 GitHub stores, 310 contributors, 1,300 forks, and 8,700 PRs. We are a CNCF project in incubation state. We're working to get to the next state, but there's a couple of obstacles that we need to overcome. But so far, it's looking pretty good that we'll reach the next stage. We have contributions from, obviously, from Red Hat, from IBM, also from Suse, from Google, from NVidia, ARM, SAP, Apple, and lots of others. So it's like a highly contributed project. And it's adopted by vendors and end users. So just to name one, of course, Red Hat OpenShift has the virtualization feature, which gives you like under the hood KubeVirt with bells and whistles, I would say. Okay, so there is an outlook to features that will at some point be implemented, but I can't guarantee anything. So, for example, like the AMD people are working on secure encrypted virtualization, memory encryption for virtual machines, which should then also like work on KubeVirt. I think there is also, I'm not that virtual machine guy, to be honest. Like I said, I'm maintaining rather the CI system. But I remember faintly that Intel has a similar feature, which is also being worked on to support that. Also, multi-arch clusters should work basically in theory. I've seen the merge request merged, but I'm saying merge request. Yeah, well, whatever. But it's not officially supported yet. And there are people from IBM working on S390X support. A general incomplete list of features. I'm not going to run through all this, but just so that you have seen it. For example, but the notable things would, for example, be like being able to give to the container or to give to the virtual machine the access of VGPUs. so that you can run your graphical workloads on that one. Yeah, we have some hardware throughput or hardware pass-through options that are related to network and also to USB and all these things that you might need. I'm pretty much confident that there might be lots of features that might be supported already. And if not, please reach out to the KubeVirt ecosystem and create an issue if there is something missing that you need. It is easy to install. Yeah, well, if it works. In general, normally you would just catch the latest release by curl command and then deploy the KubeVirt operator and the KubeVirt CR. And then you should wait until all KubeVirt components are up, and then it's up and running. Okay, so that for my talking. I hope that this condition met. Okay, that's good. Oh, come on, really? Oh, that's interesting. Oh, no. I don't know why. So what I'm seeing now is that the CDI component itself has not been deployed, which is pretty bad because like all the storage is backed by CDI component. So I would only have the option to completely redeploy the cluster, which I will do because I don't have any other option. And then I'll go on right away to Q&A while we're waiting for that and trying to recover that. So wait a second, I'm just going to tear down the cluster. And reinit. Demo prepare. Okay. Yeah, I'm not ready to thank you, by the way, but yeah, let's just start with Q&A if you have something for me.
Yeah, anyway, we have at least now one question here in Slido, so I will read. It does look like the response to the Broadcom's or VMware's hot topic these days. Will it be a competitive alternative in the near future if it is the plan?
So I think, like I said before, we don't actually have like plans to replace someone else. It's not about replacing something, and especially not like just making someone else obsolete or something like that. We are just trying to solve problems for the users. And one of these problems is like that this virtual machine, which is somewhere else, needs to get moved, and we are just trying to support that case. I hope that do you think that answers that question good enough?
I think so. If you have something to complement, please raise a hand. Either live question, give me a sign. Yeah, we have here.
Hello, my name is Vladislav. I would like to ask a few questions related to the KubeVirt in general. Oh. So first, is it running like a pod on the Kubernetes and it's managed like in the same way?
Actually, yes.
I mean the virtual machine.
The virtual machine is running inside a pod. That's absolutely correct. And so we are using KVM QEMU for that. So inside the pod, there is a QEMU process running the virtual machine.
Okay, so does it mean also, according to my understanding, that we can run Windows machines there
If
or no?
you have the basic setup for that one, yes, exactly. You could also run Windows and everything else that somehow would be feasible to run on a normal virtual machine through hypervisor. I'm not sure if that's too broad an answer, but actually we are testing with virtual machines on Windows basis.
I'm asking this because we had a situation where we utilize Docker for similar stuff, not like on the Kubernetes. And we need to run simultaneously Windows and Linux machines, and usually this is there are some issues running both of them. So if this KubeVirt allows us to spin Windows and Linux machines on Kubernetes, it could be very useful.
Should work, yes. Yeah, but the thing is, I think that, of course, like the license issues that you have normally with Windows, you need to have licenses for every Windows instance that you're running. But other than that, I don't see any problem on that. It should even support like Windows 11 with TPM. That should also work.
And one last question also.
Sure.
I saw in the presentation that you show that the machine was already created and you import it. So does it mean that we need to create this machine somewhere?
No, you don't have to. You can also like directly create the virtual machines on the Kubernetes cluster if you need that. So that's also like, I think there is even, so part of the KubeVirt project has some Tecton tasks for that actually, for like creating virtual machines inside KubeVirt so that you don't have to do all the heavy lifting. And I think that there might be even a Tecton task that you might be interested in, with which you can, I think that there should at least be a demo or something somewhere that this Tecton task is actually creating a Windows virtual machine.
And in that context, is this machine able to virtualize a GPU as well?
Windows?
Linux,
I can answer that question, to be honest. I don't know, but I would figure that it could, but don't count on me on that one. I think we would probably need to create a GitHub issue for that, so asking for that. So like I said, I'm not, oh yeah, thanks. I'm not that big into virtualization itself. That would be something specific for the people who are actually like supporting the vGPU solutions.
Okay, thank you very much.
You're welcome.
Questions are growing, so still we have like time, so let's go one by one.
Okay.
Does the KubeVirt has Terraform open tofu provider similar to Kubernetes?
That's a good question. And I'm afraid I can't answer it. I don't know. I think there was Terraform support. But yeah, I figure if there is such a thing, there should be a Terraform repository under the KubeVirt organization that holds it. I don't think that it should be outside the KubeVirt organization.
Okay, next one, already voted. One additional like, so it became up. What is the estimate of performance impact comparing VMs running with KubeVirt vs bare metal hypervisor? Do you have such like information?
VMs running with KubeVirt versus bare metal plus hypervisor. Interesting question. I don't completely get it because like we are normally suggesting that people should run KubeVirt on a bare metal Kubernetes cluster to achieve maximum performance. So since actually like the virtual machine runs on a hypervisor also, like it doesn't have like no hypervisor or something. It runs like a normal virtual machine inside a pod with a KVM-QEMU process. So there is a performance project that actually measures the performance of the KubeVirt virtual machines. And I'd suggest that you look at the KubeVirt performance repository to get detailed metrics. I'm not sure if it's actually like comparing virtual machines running on standard hypervisor, but at least you can get the data on that one. How what we are measuring there is like startup times and runtimes under load, and how many virtual machines you can run, for example, and what the performance metrics are there.
Okay, next one already was disappeared and popped up again. What does multi-architecture support means? Is it able to run different architectures, VMs in one cluster, like x86 and ARMS?
Exactly. So if you have like a mixed architecture Kubernetes clusters, we are basically supporting running like ARM workloads on ARM nodes and x86 workloads on x86 nodes.
Next one, already 2 likes. How is the communication between VMs and other pods looks like via KTS services?
Communication can either be achieved by standard Kubernetes objects, as I said, like services. You can, for example, like create a service to access a virtual machine. Also, there is the access via the console, which you can use, which I would have shown you normally. But you can also SSH into virtual machines directly. So that you can work on the KubeVirt on the virtual machine directly and just manipulate things as you need to do. There is also like support for VNC protocol, and also RDP is supported. So you could also like do a graphical management of the virtual machine if you need that.
Do we have questions live? No mics. Oh, okay, here, because yeah, let's spend this time.
Related to these services, if you SSH to the VM managed by Kubernetes and update some kernel parameters or something, which normally is ruled by the YAML and specs, how does they survive? For example, switching on some external file system or...
Oh, so okay. So you're asking
whether contradiction your local setup against the definitions in KubeConf.
So you were asking. I think this is 2 questions, but let me try to get to the first question at first. So if you're changing like the virtual machine configuration inside the virtual machine, you need to be reliant on persistent storage, of course. So normally you would do that with a persistent volume claim, which backs the virtual machine storage. So if you change something in there, it will be persisted onto the persistent volume claim, and it will survive. If you would then like restart the virtual machine, it would have all the configuration still. And the second one, I'm not sure I completely understood. Could you probably...
For example, if I change the memory configuration,
so outside of the virtual machine, you would be changing the amount of memory that was given to the virtual machine.
Yes.
So we have like support for, I think I probably, let me see if I can find that again. We have like several hot plug aspects. And memory ballooning is one of the options that is hot pluggable. I'm not sure if it's like live updatable, so that you can like on the fly extend the memory for the virtual machine, but it should be at least possible to extend the memory and then probably restart the virtual machine. I'm not sure if that is the live update is supported. There is features that are hot pluggable and that are live updatable, but honestly I don't know whether that is one of these.
Thank you very much.
You're welcome.
Yeah, and the question related to the storage from Slido. You were using Rockchip as the backend storage for the demo. Does KubeVirt support storage for all three types? File system, S3, and block storage.
Actually, KubeVirt integrates with RuxF over CDI, so you can support or choose any storage type you like.
Any live questions from the audience? No hands. So at least what I see, the last one in Slido is the difference between Kubernetes, vice versa, Open's technology.
What is OpenVZ? I have no idea. Sorry. What is that? Does anyone know what OpenVZ is? Okay, so I am not the only clueless person here. That's great. I'm feeling dumb. Okay.
Yeah, okay. There's no questions. And yeah, we see, or at least those who does demo. Yeah, we know that usually it's not according to your plan happens. Yeah. Or still we have an opportunity to see it because we have time. Yeah.
Yeah, the funny thing is now it worked, of course.
Okay. Sometimes it works like in that way.
Yeah. It was just wanting me to anger me, I think, somehow. But yeah, so. Okay, so let's get back to the demo now that it's working. So on the right side, you see two curl commands that are being permanently executed via watch. Actually, it's pretty basic. So this is like I'm simulating one service that actually just calls the Kause binary, if you know that. So it puts like messages into fancy bubbles. And the other one is like the fortune service, which is like it generates a message that that should be entertainable somehow. And by mixing these both up, I just wanted to simulate that you have like the external service that is running inside the virtual machine, and the internal service, cluster internal. I'm just doing external for virtual machine outside the cluster and internal for virtual machine inside the cluster. So the Kause service is the one that's external inside the virtual machine that is currently outside the cluster. So I'm keeping these two running because I want to demonstrate that you shouldn't see any failures inside those windows while I'm doing the things that I'm doing. Okay, so let's try to put up some... Wait a second, what's that? Ah, okay, tmux. I should open a tmux session if I need it. Okay. Okay, so I'm first of all I'm doing a watch kubectl get pods so that you can follow what the pods are doing, and also I'm not doing that. I'm just wait a second. Then I'm going to do a kubectl watch get VMIs so that you can see the virtual machine instances that are currently running. And also interesting is the virtual machine migration objects that are going to be created at a later time when we are going to live migrate the virtual machine. And as fourth, I'm not sure if I need that, but I think I have the feeling that I need something else. Well. So first of all, like I have this external virtual machine running, which I can SSH into. Okay, I'm inside the virtual machine that is running outside the cluster currently. So what I'm now showing you is that it's receiving requests from the other service, from the fortune service. And you should see like it's circling around so that you see like the requests that are going in there. So let me see. I think it's hopefully it's not getting confusing to see all those windows, and I hope you can follow. If you have questions, just shout in. Probably I'm trying to repeat those if it's okay for you. So what we also should be seeing would be so currently we are kubectl-get services. We have this fortune service that is currently running on its own, which is like generating the fortunes and then calling the Kausei service, which actually like puts this into nice bubbles and then returning that via HTTP response. Oh, okay. I hope I can just at least show you the migration. Oh no, I don't want to close this terminal. Okay. So task demo wait a second. List. So what I'm going to do now is I'm going to, inside a task, I'm going to import the virtual machine image from the external VM. What it's actually doing is, via containerized data importer, it's putting the data onto a PVC and converting that to the required format for KubeVirt, and then making that accessible. So while we're doing this, I'm just going to show you the definition of the Kausei service that will then be internal. So what you see in the upper part of the YAML is the service that is fronting the Kausei service. And in the lower, you are going to see the virtual machine definition, which I use. So what is interesting about this is like that you, for example, can use node affinity rules. If you are familiar with Kubernetes, you know, of course, that this is like a way to define where the Kubernetes objects are going to live. Oh, sorry, and I have to stop here. But just one more sentence. You can see like the domain definition, which has the hard drive that is attached to the persistent volume claim. That is the Kausei service VM disk that I just imported. Sorry for my demo not working, but yeah, in the end.
Okay, thank you. Warm applauses, yeah, to Daniel. Yeah, this is a small present from the organizers.
Oh, thank you.